Have you ever stopped to wonder how your phone or your smart speaker just knows stuff? You ask it a question and it gives you a direct answer. It feels like magic, right? Well, today we're going to pull back the curtain on that magic. We are demystifying the knowledge graph.
I mean, think about it for a second. You can ask something like, hey, who's the governor that starred in the movie Predator? And boom, you get a straight answer. It's not just searching for those specific words in a sentence. It actually understands the concepts and how a single person can wear two completely different hats, like actor and politician. How does it make that connection?
And this is exactly what's happening behind the scenes. A system can see that Arnold Schwarzenegger is the star of the movie Predator, and that same person is also the governor of California. See? Those are two totally different worlds of information, but they're both linked to the same entity. It's not just a flat list of web pages anymore. It's a real web of understanding.
This right here, this was the phrase that really changed the game. When Google officially launched its knowledge graph way back in 2012, this was their big idea. The whole goal was to stop just matching strings of text, just words, and to start understanding the real-world things those words represent. People, places, ideas, and all the crazy ways they're connected to each other.
Okay, so that brings us right to the main event. What is a knowledge graph, really? Let's break it down.
So at its core, a knowledge graph is basically a super smart database that's built like a network. You can think of it like a giant digital spiderweb of information. It's made of two simple things: the concepts, which are the real-world things we're talking about, and the relationships, which are the facts that connect them all together. And this picture shows you exactly what I mean. The circles here, which we call nodes, are the concepts: cows, herbs, animals. And the arrows, or edges, show the relationships between them. A cow is an animal, and a cow can eat herbs. Simple, right? But when you start connecting millions of these simple facts, you build this incredible web of knowledge that a computer can actually navigate and, understand.
So here's the most important takeaway. This is the difference between the old way and the new way. A classic keyword search just matched the words you typed and gave you a massive list of blue links to dig through yourself. But a knowledge graph, it understands the concepts and how they relate, so it can just give you the fact you were looking for. It's like the difference between being handed a phone book versus just being told the phone number you needed.
And this incredible tech isn't just hiding inside your Google search results. It has quietly become the invisible engine behind so many of the digital tools we rely on every single day. Let's take a look at where else these things are hiding.
So when you ask Siri or Alexa for the capital of France, that's a knowledge graph at work. When LinkedIn suggests someone you might know, or Facebook automatically tags your friend in a photo, yep, knowledge graph. Amazon uses them to recommend what you should buy next, Uber uses them to get you from point A to B, and scientists are even using them to map out these incredibly complex relationships in things like genomics. Seriously, they are everywhere.
Now, this idea didn't just pop up overnight. It's been evolving for decades. It really started back in the 80s with academic projects like WordNet, which was this huge effort to map out how words relate to each other. Then, in the 2000s, we got these massive public datasets like DBpedia, which was literally built by pulling structured data out of Wikipedia. Of course, Google's big launch in 2012 is what made the term famous. And now, we're seeing the next big leap. Companies like Microsoft are plugging them directly into the latest and greatest AI models.
But as you can imagine, building these incredibly powerful webs of information is not easy. And as more and more of these knowledge graphs get created by different companies for different reasons, a massive challenge pops up. How do you get them all to talk to each other?
Let's go back to our buddy Arnold for a second. Imagine one database has an actor listed as Arnold S., and a completely different one has an actor named Schwarzenegger, starring in the same movie. Now, you and I know they're the same guy, but how does a computer figure that out for sure? Solving this is way more complicated than it sounds, and it's a huge focus of research.
So there's actually a technical name for this giant puzzle. It's called entity alignment. And it's this absolutely critical process of figuring out that the Arnold S from one graph and the Schwarzenegger from another are in fact the exact same person. Once you know that, you can merge all their information and build a much richer, much more accurate picture. So how do they actually do it? Well, you can think of it as a super high-tech game of connect the dots. First, algorithms analyze all the details, the attributes, things like birth dates, movie credits, you name it. Next, they compare relationships. Do both of these entities have a connection to California or to the movie studio? And finally, based on all those similarities, they make a prediction. And if it's a match, poof, the records get merged.
And all of this work, defining concepts, mapping relationships, aligning all these different sources,
It is more important right now than ever before. Why? Because it's sitting at the absolute heart of the biggest technological revolution happening today: artificial intelligence.
The future of really smart AI is all about this incredible partnership. On one side, you've got large language models, or LLMs. These are the incredibly creative, fluent systems that can write you a poem or an email. And on the other side, you've got knowledge graphs, structured, factual, and totally verifiable webs of information.
So what happens when you put them together? Well, something pretty amazing. The knowledge graph acts like a factual backbone. It grounds the super creative LLM in cold, hard reality. This is a huge deal because it helps cut down on errors, or those infamous AI hallucinations where the AI just confidently makes stuff up. It allows the system to not just generate text, but to actually reason, creating answers that are way more accurate and, most importantly, trustworthy.
And this powerful technique has a name. It's called retrieval augmented generation, or just RAG for short. It's basically the process of an AI model looking up facts in a knowledge base, like a knowledge graph, before it gives you an answer. This isn't just a theory, it's the cutting edge. This is how the next generation of AI is being built as we speak.
And all of this leaves us with one last, really big question to think about. These knowledge graphs are quickly becoming the foundation for how AI actually sees and understands our world. As these systems get more and more powerful, the accuracy of that foundation is everything. So it makes you wonder, who's fact-checking the AI's fact-checker?